Hello students, what is going on? My name is Abdullah Momin from KMES English Medium High School and Junior College, and in this video we are going to start chapter number 8, that is sound, and we are going to see the introduction part of this chapter, and this chapter is from class 11th physics. So first of all, the question is, what is sound? So sound is a wave. Then we will see that what is a wave. But before that, we have observed that when a stone is thrown in the water, the ripples are being created on the water surface like this. And these ripples are nothing but wave, and when these ripples created on the surface of the water molecules will move up and down, and these ripples are going to spread in bigger and bigger circles. So this is nothing but wave. And the definition of wave, we will say that wave is a disturbance traveling through the medium due to the continuous vibration of the particle of the medium. Now suppose a person is tie a rope and the other end is being held by it, and when it start giving the pulse, the movement of the hand will up and down, which is in the direction of this red arrow, and the wave or the energy will move in a forward direction. So the particle of this rope will move in up and down. In this diagram, these small spheres indicating the particles of the rope. When these particles move up and down, the disturbance will travel through the medium or travel through the rope. In this case, the rope is a medium. So what is wave? Wave is nothing but the disturbance traveling through the medium due to the continuous vibration of the particles of this medium. Particles are being disturbed and wave will travel in a forward direction. Now, types of wave. So we will say that there is a three types of wave. First is mechanical wave. Mechanical wave, the examples are the waves which are created on the rope or string, or waves are the example of mechanical wave. Second type of wave is electromagnetic wave. X-ray, microwave, radio waves are the examples of electromagnetic waves. And the third type of wave is matter wave, which is associated with moving object. But in this chapter, we are going to study about the mechanical wave in details. But before that, will study the some common properties of all the wave. So the very first property is amplitude, which is denoted by A, and it is defined as the maximum displacement of particle from its mean position is called as amplitude of the wave, and the unit SI unit of the amplitude is meter. Suppose a wave is created on this rope, so the maximum displacement should be measured. We are going to measure it from this mean position, and this displacement is called as amplitude. If this is 5 centimeter, this distance is 5 centimeter, this dash line is the mean position of this rope before developing a wave in it. The position of the rope is a straight line, so this is your mean position of the wave. And when the wave start traveling in a medium, the particle get displaced from its mean position, and that maximum displacement is called as amplitude of the wave. So here, if this distance is 5 centimeter, so we will say that this distance is also 5 centimeter, and the amplitude is 5 centimeter. But in SI unit, we will measure the amplitude in meter. Now the second property of wave is wavelength, which is denoted by lambda, and it is defined as the distance between the two successive particles which are in the same state of vibration is called as wavelength of the wave, and its unit is meter. Now suppose a wave is being created, and when the wave, this part is called as crust and this part is called as trough. So one wave, the length from this end to this end is called as lambda, and it is nothing but wavelength of the wave. This portion is called as crust and this portion is called as trough, and the distance between this crust and trough is called as wavelength of this wave. Now the third property of the wave is period, and which is denoted by capital T, and it is defined as the time taken for any particle to complete one vibration is called period of wave, and the SI unit is second. Now suppose a particle is vibrating here up and down, and when this particle start vibrating, first it will move in upward direction, then after reaching to the extreme point or after getting to the maximum displacement, it comes back towards the main position. Initially, when it starts its motion, it will move in upward direction. Then after reaching the maximum displacement, it is going to come back in downward direction, and its motion will be continue. And after reaching the extreme position, it will again come back towards the main position. So this set of motion is called as one vibration. This is called as one vibration, and the time taken by the particle to complete this much amount of motion, this much amount of motion is called as time period. The time taken by the particle to complete one vibration or one oscillation is called as time period of the wave. Now the fourth property is double periodicity. What do you mean by double periodicity? So the first point is, at every location, the wave motion repeats itself at equal interval of time. Hence, it is periodic in time. Now, one crust and one trough is developing in 5 seconds. So, after this, the next crust and next trough will also develop in 5 seconds. And after that, again one crust and one trough will develop in a 5 seconds. So we will say that after equal interval of time, one set of crust and trough is developing, and this one set of crust and trough is nothing but time period, and we will say that it is periodic in time. And it is also repeats, this wave also repeats itself after a equal distance. The wave repeats after equal distance, hence it is periodic in space. The distance between this portion and this portion, suppose this distance is 10 meter, so the next wave will repeat one crust and one trough in the same distance, that is 10 meter. And if we will say that it is 50-meter long wave, that means 5 crust and 5 trough is being developed on it. Now the next property of the wave is frequency, and it is denoted by a small n. So what is frequency? Frequency is the number of vibration performed by the particle. So since the particles are vibrating about their mean position, they are moving in upward and downward direction. So the number of vibration performed by the particle in 1 second is called as frequency. Suppose a particle vibrates 4 times in 1 second, then we will say that its frequency is 4 hertz. And hertz is the SI unit of this frequency. SI unit of the frequency is hertz, and it is denoted by Hz. And we will say that the frequency is the reciprocal of time period. That means n is equal to 1 upon t. Now next property of wave is velocity. And we know that the magnitude of velocity is speed, and it is defined as the distance covered by a wave per unit time. So velocity can be written as distance upon time. One crust and one trough, that distance is nothing but lambda, and the time taken by the wave to reach from this point to this point is nothing but the time period. So its distance is lambda, the time is capital T. So we will put this in this equation. We will say the distance is lambda and the time is capital T. And we know that 1 upon T is nothing but n. So V can be written as n lambda, where V is the velocity, n is the frequency, and lambda is the wavelength. So we will say that velocity is equal to frequency times wavelength, or V is equal to n lambda. Now this equation indicates that the magnitude of velocity of a wave in a medium is constant. V is constant, but increase in frequency of a wave causes decrease in wavelength. V will remains constant, but if we will increase the frequency, wavelength decreases. If we will increase the wavelength, frequency will decreases, but V will remains constant. When a wave goes from one medium to another medium, the frequency of the wave does not change, means frequency will be constant, but in such case speed and wavelength of the wave changes. Suppose the wave is traveling from air to water, so when a wave enters in the water, its frequency remains constant, but its wavelength changes and its speed changes. Now the wave required a material medium, and that medium should possess a certain property, and the medium should be continuous and elastic so that the medium regains original state after removal of deforming force. Since this is the rope, and we will say that this is the medium in which wave is traveling, if this medium loses its continuity, means we are going to remove this particle, so this wave will not reach from initial point to final point. So in order to reach the wave from initial point to final point, the medium should be continuous and it should be elastic. Elastic means after removal of force, it it should regain its original state or original shape and size. The second property of the medium is the medium should possess inertia, means the medium must be capable of storing energy and transferring it in the form of wave. These particles will store energy and will transfer the energy to its neighboring particle, and again this particle will store the energy and this particle transfer the energy to its neighboring particle. Like this, the energy will be transferred from one end of the wave to another end, and this property is nothing but inertia. Now the frictional resistance of the medium must be negligible so that the oscillation will not be damped. If there is so much resistance in the air, the wave is ultimately, the oscillation is going to die, and this particle will stop its oscillation after a certain amount of time if there is a frictional resistance. But if there is no resistance, then this particle will continues to vibrate, and if these particles are continuously vibrating, that means the wave is continuously traveling, and if the wave is continuously traveling, then it is a progressive wave. So we will say that the medium should have negligible frictional resistance so that the oscillation will not die. So that's it, student. This is it. I will catch you next time.